Students and friends, this is your host and teacher Sayyid Ayazuddin Haider, and you are watching Learn and Teach by Sir Ayaz. So I was doing the paper 0620 and I'm done till variant 41. This time I have selected the variant 42. It's May-June 2023. I'm not going to read the instructions as you all are aware of the instructions. So let's start the paper. Number one, a list of oxides A to H is shown. A. Calcium oxide. B. Aluminum oxide. C. Silicon 4 oxide. D. Sulfur dioxide. E. Carbon dioxide. F. Iron 3 oxide. G. Silver oxide. H. Carbon monoxide. Answer the following questions about the oxides A to H. Each letter may be used once, more than once, or not at all. State which of the oxides A to H A is responsible for acid rain. So if you look at the oxides, you will find some non-metal oxides in the list. Silicon oxide, silicon 4 oxide is a non-metal oxide, sulfur dioxide, carbon dioxide, and carbon monoxide. So we have three acidic oxides here. All these three are acidic oxides. But the oxide which is responsible for the acid rain is sulfur dioxide, not other two. Carbon dioxide also form acidic solution, but it is not the main culprit behind the acid rain. So I will write D here. B has a giant covalent structure. So we have covalent structures, silicon 4 oxide, sulfur dioxide, carbon dioxide, and carbon monoxide. But silicon 4 oxide is the only one which has giant covalent structure. So C will be the answer here. Number C is a reducing agent in the blast furnace. In the blast furnace, during the reduction of iron 3 oxide, this is the reaction equation, Fe2O3, carbon monoxide is the main reducing agent. We will get iron and carbon dioxide. I'm not going to balance the equation this time. So carbon monoxide will be the answer for this part. H. D is a main constituent of bauxite. What is bauxite? Bauxite is the ore of aluminium. And the main constituent of this bauxite is aluminium oxide. So B will be the answer for this part. E is the main impurity in iron ore. The main impurity in iron ore is silicon 4 oxide. Here is silicon 4 oxide, so I will write C here. Part F can be reduced by heating with copper. If you heat it with copper, it can be reduced. So this metal oxide must contain the metal which must be lower in the reactivity series than copper, and it must be not other than this silver oxide in these choices. So I will write G here. Moving to next question. Number 2, fluorine, chlorine, and bromine are in group 7 of the periodic table. A. State the name given to group 7 elements. Here we have group 7. These are the group 7 elements. We have fluorine, chlorine, bromine, iodine, astatine, and tennessine. So they are known as halogens. B. Explain why group 7 elements have similar chemical properties. If you look at these elements, look at the group number. Group number tells us the number of valence electrons. They all are having same number of valence electrons or outer shell electrons. So you write same number of valence or outer shell electrons. C. Complete table 2.1 to show the color and state at RTP of some group 7 elements. We have fluorine, chlorine, bromine. Fluorine is pale yellow gas at room temperature and pressure, so I will write gas here. What about chlorine? Chlorine is yellow-green gas, yellow-green gas at room temperature and pressure. Bromine is reddish-brown or red-brown liquid. Part D. Bromine has two naturally occurring isotopes, Br79, Br81. Number one, state the term given to the numbers 79 and 81 in these isotopes of bromine. They are either nucleon number or mass number of these isotopes. Nucleon or mass number. If you look at the periodic table, here you have bromine. You can see 80 and 35. Small number is the proton number. Big number is the nucleon number. Number 2. Complete table 2.2 to show the number of protons, neutrons, and electrons in the atom and ion of bromine shown. So we'll look at the periodic table in order to see the proton number of bromine. Here it is bromine. Proton number is 35. So number of protons should be 35 for both of these straight away. For bromine 79, I need to subtract 35 from 79 in order to get the number of neutrons. 79 minus 35, 44. What about the electrons? Electron, it's a neutral atom, so electron number should be same, 35. What about Br minus 81? So 81 minus 35. 81 minus 35. 46. 46 is the number of neutrons. What about number of electrons? If you see there's a minus charge, so it means it has gained one electron. Gained one electron. So I will add 35 plus 1. 36 will be the number of electrons for this ion. Number 3, table 2.3 shows the relative abundances of the two naturally occurring isotopes of bromine. We have bromine 79, 55%, bromine 81, 45%. Calculate the relative atomic mass of the bromine to 1 decimal places. So what we will do, we will multiply the mass or nucleon number of each of these isotopes by the relative abundance. So we have 79 multiplied by 55 plus 81 multiplied by 45 divided by 100. 79 multiplied by 55 will get 4,345 plus 81 multiplied by 45, 3,645 divided by 100. 4,345 plus 3,645 divided by 100. What we will get? We will get 79.9. This will be the final answer for this question. E. Chlorine displaces bromine from aqueous potassium bromide but does not displace fluorine from aqueous sodium chloride. Number 1, write the symbol equation for the reaction between chlorine and aqueous potassium bromide. Chlorine, they are halogens, they all exist in the diatomic state, so I will write Cl2 for chlorine. What about potassium bromide? Potassium bromide, KBr. Bromine, here we have bromine, it's in group 7, so valency is -1. Potassium, here we have potassium in group 1, valency is +1. So if you ignore their charges, you have 1, 1, and do the cross, what you will get? You will get KBr. So KBr will be the formula for potassium bromide. The product will be KCl and Br2. Bromine is also halogen, so it will also exist in the diatomic state. Let's balance the equation. Place 2 here and 2 here. This will be the final balanced equation between chlorine and potassium, aqueous potassium bromide. Number 2, state why chlorine does not displace fluorine from aqueous sodium chloride. If you look at the position of chlorine, here we have chlorine and fluorine is on the top, and you know the reactivity trend, it decreases down the group, which means that chlorine will be less reactive than fluorine. Chlorine less reactive than fluorine. F. Aqueous silver nitrate is a colorless solution containing Ag plus aqueous ions. Number 1, describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. So this aqueous silver nitrate is also used to identify the halide ions, that is Cl negative, Br negative, and I negative. So Cl negative ion will be identified through the change in color. The change in color will be white precipitate or white PPT. White precipitate. Number 2, write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium chloride. Include state symbols. So here we have a reaction between silver nitrate and aqueous sodium chloride. The formula for aqueous silver nitrate is AgNO3. It's an aqueous state, plus sodium chloride. Sodium in group 1, chlorine in group 7. So the valency will be 1 for both of these. The final formula will be NaCl, aqueous. This is an example of displacement reaction as well as precipitation reaction. So what will happen? The partners will be exchanged. Ag will combine with Cl and Na will combine with NO3. So what we'll get? We'll get AgCl. AgCl will be in solid state, and NaNO3 will be in aqueous. NaNO3 aqueous. Now, in order to write the ionic equation, I need to break up the aqueous only, not solid. This will not break up. Not break up. Okay, so AgNO3 will get Ag plus aqueous plus NO3 minus aqueous plus Na plus aqueous plus Cl minus aqueous gives AgCl solid plus Na plus aqueous plus NO3 minus aqueous. So spectator ions will be cancelled out. On both sides of the equation, you will see NO3 is a spectator ion as well as Na. These will be cancelled out. So in the end, we will be left with these ions. Ag plus aqueous plus Cl minus aqueous gives AgCl solid. This will be the final ionic equation. So I will write it down here. Ag plus aqueous plus Cl minus aqueous gives AgCl solid. Question number 3. Over 200 million tons of sulfuric acid are manufactured every year. A. State the name of the process used to manufacture sulfuric acid. The name is contact process, so you write contact process here. B. Part of the manufacture of sulfuric acid involves converting sulfur dioxide to sulfur trioxide. Number 1. Describe two methods by which sulfur dioxide is obtained. Now you can burn sulfur in air, or you can involve sulfur ores like zinc blend and roast it. So I will write burning of sulfur. Burning of sulfur in air, or you can have you roast sulfur ore, sulfide ores in air like zinc blend. Zinc blend is ZnS. The conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. This is a reaction to SO2 gas plus O2 gas gives 2SO3 gas. Number 2, state two features of an equilibrium. So you have to write two features of the equilibrium. So the concentration of reactants and products remain constant or are no longer changing. Concentrations of reactants and products are no longer changing. The rate of number 2, the rate of forward reaction is equal to rate of backward reaction. Number 3. State the typical conditions and name the catalyst used in the conversion of sulfur dioxide to sulfur trioxide. These are the conditions. We have 450 degrees centigrade as a temperature, and we have 200 kilopascal as a pressure, and catalyst is vanadium 5 oxide. Vanadium 5 oxide. Moving to next part of this question. Number 4, complete table 3.1 to show the effect, if any, when the following changes are applied to the conversion of sulfur dioxide to sulfur trioxide. Here's the equation. The forward reaction is exothermic. Only use the words increases, decreases, or no change. So what will be the effect on the rate of the forward reaction if temperature decreases? What about the concentration of SO3 at equilibrium? Forward reaction is exothermic, you see, so it should favor low temperature. So it will definitely increases if you decrease the temperature. Now what happened if you increase the pressure on the rate of reaction? It increases, and for the effect on the concentration of SO3 at equilibrium, if you see the number of moles on the reactant side is 3, product side is 2. So it should favor high pressure. So you'll have high concentration of SO3 at equilibrium. So you write increase. What about catalyst? If you are not using any catalyst, so the rate will be decreased. But what about the concentration? Catalyst has no effect on the equilibrium. So you write no change. Next part, number 5, explain in terms of collision theory why reducing the temperature decreases the rate of the forward reaction. So kinetic energy of the particle decreases, frequency of collisions between particle decreases, and you are having fewer particles having energy greater than or equal to activation energy. This is of 3 marks. So you have to write 3 statements. Kinetic energy of the particles decreases. Frequency of collision between particles decreases. You have fewer particles have energy greater than or equal to activation energy. Number C, sulfuric acid contains SO4 2 minus ions. The oxidation number of O atoms in SO3 2 minus ions is -2. Determine the oxidation number of S atoms in SO3 2 minus ions. Show your working. So we have one atom of S. So I will write X here for S plus. There are 4 atoms of oxygen. What is the oxidation number of oxygen? It's -2. So I will write -2. And what is the charge on the ion? The charge on the ion is 2 minus. So I will write -2 here. So X -8 is equal to -2, or X is equal to -2 plus 8. You will get +6. So +6 will be the final answer. Here's question number 4. Solid sodium hydroxide is a base which dissolves to form an aqueous solution, NaOH aqueous. A. State what is meant by the term base. They are proton acceptors. B. State the term given to a base which dissolves to form an aqueous solution. They are metal hydroxides. Technically, they are known as alkali. C. State the color of thymophthalein in NaOH aqueous. NaOH aqueous is alkali, so it must be blue. In alkali, it shows blue color. It gives blue color. D. Complete the word equation for the reaction of NaOH aqueous with ammonium chloride. Ammonium chloride is ammonium salt. So whenever you react ammonium salt with alkali, here sodium hydroxide is alkali, what you will get? You will get 3 products. You will get ammonia, water, here I will write ammonia, water, and the salt. Salt obtained must be formed between sodium and chloride. So we will write sodium chloride. E. Some metal oxides react with NaOH aqueous. Metal oxides mean they are bases. Number 1, state the term given to a metal oxides which react with bases such as NaOH aqueous. Now there are some oxides which react with both acidic oxides, that's non-metal oxides, and metal oxides. They are known as amphoteric oxides. So I will write amphoteric. oxide here. Number 2, name a metal oxide which reacts with NaOH aqueous. You have two oxides in your syllabus which act as amphoteric oxide. This is aluminum oxide or zinc oxide. Aluminum oxide or zinc oxide. F. Ethanoic acid CH3COOH is a weak acid. Number 1. Complete the dot and cross diagram in figure 4.1 of a molecule of ethanoic acid. Here they have shown the key for both the carbon atoms as well as oxygen. I am only going to show the key for hydrogen atom. I am using blank dot for each hydrogen. And you can see hydrogen have only one electrons. Its proton number is 1. It has only one valence electron. What about carbon and oxygen? Carbon, here it is carbon, it belongs to group 4. It has 4 valence electrons. Oxygen, it belongs to group 6. It has 6 valence electrons. So for hydrogen only, we have to place one valence electron for each hydrogen atom. Here, one electron for this hydrogen, one for this hydrogen, one for this hydrogen, one for this hydrogen. What about carbon? It contains 4 valence electrons. For the carbon on the left hand side, 1, 2, 3, 4. For the carbon on the right hand side, 1, 2. Now, the last 2 electrons will form a bond with the oxygen on the right hand side because it's a double covalent bond. So you'll have 2 valence electrons placed here. What about oxygen? Oxygen have 6 valence electrons. So 2 electrons are already shown for the oxygen atom which is attached to hydrogen. 1, 2, 3, 4, 5, 6. Now the oxygen which is attached to carbon, 2 of the valence electrons will be shared with the carbon. 1, 2, 3, 4, 5, 6. So this will be the final dot and cross diagram for ethanoic acid. Number 2, suggest the pH of dilute ethanoic acid. Ethanoic acid is a weak acid. So the pH must be between 3 and 7. Number 3, complete the symbol equation to show the dissociation of ethanoic acid. As I've just told you, it's a weak acid. So we'll show the reversible sign for the dissociation of ethanoic acid. This is a formula of ethanoic acid. This is a sign for dissociation. And it will dissociate incompletely, forming CH3COO negative and H positive ion plus H positive ion. Number 4, write the ionic equation for the reaction when an acid neutralizes a soluble base. Soluble base means alkali. So whenever acid neutralizes a soluble base, H positive ion from the acid and OH negative ion from the soluble base reacts to form water. So the ionic equation will be H positive plus OH negative gives H2O. Moving to next question. G, in a titration 25 centimeter cube of 0.08 mole per dm cube aqueous potassium hydroxide KOH aqueous is neutralized by 20 centimeter cube of dilute sulfuric acid H2SO4 aqueous. This is a reaction equation. 2KOH aqueous plus H2SO4 aqueous gives 8K2SO4 aqueous plus 2H2O liquid. Calculate the concentration of H2SO4 in gram per decimeter cube using the following steps. Calculate the number of moles of KOH used. So you need to calculate the number of moles of KOH used. Here the information is 25 centimeter cube of 0.08 mole per dm cube of aqueous potassium hydroxide. So first of all, I will convert this into centimeter cube. You know the relationship for dm cube and centimeter cube, 1 dm cube. contains 1000 centimeter cube. So I will write 1000 centimeter cube contains 0.08 moles of KOH. Therefore, 25 centimeter cube contains X moles of KOH. So 0.08 multiplied by 25 divided by 1000 will get 0.002 mole. Determine the number of moles of H2SO4 which react with the KOH. Now we need to calculate the number of moles of H2SO4 which is reacting with KOH. Here's the relationship. So 1 mole of H2SO4 react with 2 moles of KOH. Therefore, X mole of H2SO4 react with 0.002 moles of KOH. Do the cross in order to find the value of X. We will get 2X is equal to 0.002 or X is equal to 0.002 divided by 2. What we will get? 0.002 divided by 2. 0.001 moles of H2SO4. Now calculate the concentration of H2SO4 in mole per dm cube. Coming back to the question again, you can see 20 centimeter cube of sulfuric acid is used here. So these are the moles in 20 centimeter cube. So what you will write? 20 centimeter cube contains 0.001 mole. Therefore, 1000 centimeter cube contain X mole. So we will have X is equal to 0.001 divided by 20. 0.001 divided by 20. You will get, so we need to multiply 0.001 by 1000 also. I need to write it again. 0.001 multiplied by 1000 divided by 20. 0.001 multiplied by 1000 and now it's divided by 20. 0.05 mole per dm cube. Next part, calculate the concentration of H2SO4 in gram per dm cube. For this, we need to calculate the MR of H2SO4. MR of H2SO4. We have 2 atoms of hydrogen. 2 will be multiplied by, here is hydrogen. 1 is the mass number of hydrogen. What about sulfur? Here is sulfur. The mass number is 32. Oxygen. Here is oxygen. Mass number is 16. So 2 multiplied by 1 plus 1 multiplied by 32 plus 4 multiplied by 16. So we'll get 2 plus 32 plus 64. So we will get what? We will get 98. So in order to get the mass, we need to calculate the moles into MR. So moles is 0.05 and it will be multiplied by MR, 98. 0.05 multiplied by 98. 4.9 gram per decimeter cube. Moving to next question. Number 5, propane and propene both react with chlorine. A. When a molecule of a propane C3H8 reacts with chlorine in the presence of ultraviolet light, one atom of hydrogen is replaced by one atom of chlorine. Number one, state the term given to a reactions in which one atom in an alkane is replaced by another atom. These are substitution reactions. So you write substitution. Number two, state the purpose of ultraviolet light. It's providing activation energy. Provide activation energy. Number three, state the term given to any reaction in which requires ultraviolet light. We call it photochemical reaction. The reaction catalyzed by light, photochemical reaction. Number four, write the symbol equation for the reaction between propane and chlorine. This is a formula for propane, C3H8 chlorine. It belongs to group 7. Here we have chlorine. They all exist in diatomic state. So you'll write plus 32. One of the atom, that is hydrogen, will be replaced by chlorine. So you'll write C3H7Cl and plus HCl. So these are the two products obtained in this reaction. B, a molecule of propene C3H6 is unsaturated and will react with chlorine at room temperature. Number one, state why propene is an unsaturated molecule. It contains carbon-carbon double bond. It contains carbon-carbon double bond. Or you can even write it has a carbon-carbon bond which is not a single bond. Which is not a single bond. Number two, give the structure formula of the product of this reaction. So we need to draw the structure formula of the product of this reaction. This is an addition reaction. You simply have to add chlorine molecule to propene. So in order to draw the structure formula, how many carbon atoms are there? There are 3 carbon atoms. You need to show the condensed formula. The formula will be like this: CH3, CHCl. You have to add chlorine atom to do 2 different carbon atoms. Chlorine molecule will not attach to single carbon atom. It will go to 2 different carbon atoms, especially those that having double bond, adjacent double bonds. CHCl, and we will get CH2Cl. This will be the final formula. Number C, propene undergoes addition reactions with steam. There are 2 possible products, A and B. Draw the displayed formula and name each product. Displayed formula of product A. So propene is undergoing addition reaction with steam. We need to draw the displayed formula of 2 products. So I'm going to draw the displayed formula of propene first. Here we have propene, 1, 2, 3. So I'm placing double bond on the right hand side. So let's saturate the bonds of carbon on the right hand side. 1, 2, 3, 4. 1 second carbon atom, 1, 2, 3, 4. Last carbon, 1, 2, 3, 4. Placing the hydrogen atoms. So this is the displayed formula of propene. Plus steam. The formula for steam is HOH. So these steam will form a bond with this propene, producing products with 2 possible structures. So either this OH will attach to this carbon, situation number 1, I will write it here, or it will attach to this carbon. This will be B. This hydrogen will definitely attach to another carbon atom at the same time, forming the addition product. The addition product is known as alcohol here. This is alcohol. We are getting alcohol, and in this case, we will get propanol. Propanol. So if the OH is attaching to the first carbon, that is on the right hand side, let's call it first carbon, 1, 2, 3. We will get propane 1 all. Name will be propane 1 all. Displayed formula will be this: 1, 2, 3. Attaching OH. This will be the final formula for propane 1 all. What about the displayed formula of structure B? In structure B, OH will be attached to second carbon. So we'll get propane 2 all. Propane 2 all. Displayed formula will be this: 1, 2, 3. This time I'm attaching OH to the second carbon. OH. It's up to you whether you can place it at the bottom or the top of this carbon. I'm saturating the carbon. So this will be the final displayed formula for propane 2 all. Moving to next question. Number 6, carboxylic acids can be converted to esters. A. Name the ester formed when butanoic acid CH3, CH2, CH2, COOH reacts with ethanol CH3, CH2OH. So the other name for ester is also alkyl alkanoate. The alkyl group is coming from the alcohol. So here we're getting alkyl group. And in this case, we will get ethyl. And alkanoate group will be coming from the carboxylic acid, which is butanoic acid in this case. So you will get ethyl butanoate. Ethyl butanoate. B. Identify the other product formed in this reaction. Water, or you can even write the formula of water, H2O. C. Deduce the empirical formula of the ester formed. So first of all, I need to draw the formula for ester, then I will draw the molecular formula, then we'll make the empirical formula of this ester. So here we are having butanoate group coming from this butanoic acid and alkyl group, that is ethyl group, coming from this ethanol. So the formula will be CH3, CH2, CH2, COO, CH2, CH3. Now I am writing the molecular formula. So how many carbon atom? 1, 2, 3, 4, 5, 6. So you'll have C6. What about hydrogen? 3, 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 3, 12, H12. What about oxygen? 2 oxygen, 1, 2, O2. So the empirical formula for this ester will be C3H6O. This will be the empirical formula for the ester form. D. PET is a polyester. Part of the structure of PET is shown in figure 6.1. This figure 6.1. Number 1, circle one repeat unit of this polymer. I have to circle one repeat unit of this polymer. This will be the repeat unit of this polymer. Either you can circle this one, or this one, or this one, or this one. Any one of these. Any one of these 4 circles. Number 2, draw the structures of the monomers which make up PET. Draw the functional groups using displayed formula. So we'll go to the in reverse direction in order to draw the monomers for these for this PET. So for this one, what we will do, we will need to attach OH on adjacent end. So we will get this C double bond O, C double bond O, simply attach OH. This will be the one functional group. What about second functional group? This one is repeated after this one. So we'll get HO bond. So we have diol and dicarboxylic acid. This is diol and this one is dicarboxylic acid. Number 3, state the type of polymerization used in making PET. It's condensation polymerization. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.